to our channel. So in today's session we'll discuss one more topic in automata theory, that is how to convert the NFA with epsilon moves to without epsilon moves. So we have seen what about this epsilon, right? So it's an empty move, so without any input symbol we can change the one state to another state. And here we have to convert this NFA with epsilon to NFA without epsilon, because it is not feasible in the implementation part. So we need to convert this to DFA. So before going to convert it to a DFA, first we need to convert this with epsilon to without epsilon, and then we have to convert it to a DFA. So first of all, in the previous session we have discussed about the closures, right? Epsilon closures. So first step is we need to find the epsilon closures for all the states. So we know that epsilon closure for the particular state is the epsilon moves for the particular state, right? So we have discussed about this epsilon closure in the previous sessions, and don't worry if you don't know about this one. So I will provide the link in the description section. Just follow that one and get an idea about how to find out this epsilon closure and what about the NFA with epsilons and all these things, and then you just follow this session, right? Now the first session is we have to find the epsilon closure, and the second step is we need to find the transitions, right? So for example, delta of a Q with the input symbol A is equal to epsilon closure of, again, a delta of epsilon closure of a Q and with the input symbol A. So you just remember this function. So we need to apply this function in order to find the transition of a Q, any state with any input symbol. So we need to find the states with all the input symbol. For example, here you need to find the Q0 with A, Q0 with B, Q1 with A, Q1 with B, Q2 with A and Q2 with B, right? By applying the same function, and we'll get a different states. And after the third one, we have to decide the final state. So what is the final state? So like f dash is a final state, right? For example, so let me explain. If f, q, delta, all these are the functions, okay, 5 tuples for NFA with epsilon move, right? Then f dash, q dash, delta dash, all these are the NFA without epsilon. So we need to find this one, f dash, q dash and delta dash. So that's why I have given delta dash, right? So here f dash, we need to find the final states. We have to find the final states, and the final states will be f union q naught, f union q naught if epsilon closure of q naught is having f as a member, So if epsilon closure q naught is having the f as a member, f is nothing but a final state of this one with epsilon. So as a member, then this will be the result, okay? Q naught should be included in the final state, and only f otherwise. That means if f is not a member of epsilon closure of q naught, then automatically f will be the remain same, right? That means that it will be the final state. So this is the step we need to follow. So only the 3 steps. First we need to find the epsilon closure, and then we have to find out the transition for every input symbol, and then we have to find the final state, right? So let us start solving this one. So we have to convert this one. So you can observe here we are having some epsilon moves, right? And we need to convert this epsilon moves to without epsilon, right? So I will write this function here itself, right? So delta dash of q comma a is equal to epsilon closure of delta of epsilon closure of q with the a input symbol. So just remember this one, okay? Now first of all we need to find the epsilon closures. So epsilon closure of q naught, we need to find the epsilon closure of q naught, epsilon closure of q1 and epsilon closure of q2, right? So epsilon closure means the states which are reached from that particular state with the epsilon move. So you can observe here, and as I have said that earlier, every state will be having a self transition with epsilon move. So Q naught, first Q naught will be there, and from Q naught, is there any epsilon move? Yes. So from Q naught with epsilon you can move to Q1, and again from Q1 with epsilon we can move to Q2. So this is the epsilon closure of Q naught. Now Q1, epsilon closure of Q naught, Q1. So from Q1 you can move to Q2 with the epsilon move. So first of all let us write Q1 and next Q2, and from Q2 is there any epsilon move? No. So epsilon closure of Q1 is Q1 comma Q2. Now epsilon closure of Q2. So Q2 itself will be the epsilon, because every state will be having a self transition with epsilon move, right? So Q2, and is there any epsilon move from Q2? There is no epsilon move. So this is a epsilon closure for Q2. Okay, so just remember these things. Okay, just remember these things, and this is the epsilon move. Now we need to find this function. Okay, the first step is completed. We have find out the this epsilon closures for all the states Q0, Q1, and Q2. Now the delta of, what is this one? Q0 on A, Q0 on A is equal to, just apply this one, epsilon closure of delta of epsilon closure of Q0 comma A. Okay, here let us write here the final result. Okay, first we find it, we write here. So you can observe here epsilon closure of delta of epsilon closure of Q0. What is this? Epsilon closure of Q0 comma A. Epsilon closure of Q0 is, you can see here a Q0, a Q1 and a Q2 comma A. So this we can write it as epsilon closure of, see, delta of Q0 comma A union delta of Q1 comma A union delta of Q2 comma A. So we have just expanded this one. So delta of Q0, Q1, Q2 comma A can be written as delta of Q0 with A union delta of Q1 with A union delta of Q2 with A. Now just write down here. So epsilon closure of delta of Q0 in A, Q0 on A. So there is no move. So that is phi. There is no move on input symbol A. Union delta of Q1 on A, Q1 on A itself, right? So there is a self transition like Q1 union Q2 on A. Q2 on A, again you can see, again it's a Q1. So you can observe here phi union Q1 union Q1. So that implies epsilon closure of Q1. So epsilon closure of Q1, you can see here it is Q1 comma Q2. So function of Q0 with A is equal to Q1 comma Q2. Just remember this one. So I will write here delta of Q0 comma A is equal to Q1 Q2. Right? I will write down here. Okay, everything we have to write down here. Hope you understood this one. So epsilon closure of delta of epsilon closure of Q0 comma A. So epsilon closure of Q0 is nothing but Q1 Q1 Q0 Q1 Q2. So Q0 Q1 Q2 of A. So expand this delta. So delta of Q0 on A, the union delta of Q1 on A, union delta of Q2 on A. So phi union Q1 union Q1. So we will get the epsilon closure of Q1, which is nothing but Q1 and Q2. So delta dash Q0 on A is nothing but Q1 comma Q2. So I have written it here itself. Now we need to find every transition for every input symbol. So now you have to go with Q0 on B. Q0 on B. So here I replace this A with B. Okay. Now again repeat the same process. So closure of delta of epsilon closure of Q0. So epsilon closure of Q0 is a Q0, Q1, Q2, comma B. Hope you understood this one, right? Again, we need to expand this one. We need to expand this one. Now you can observe here epsilon closure of delta of Q0 on B union delta of Q1 on B union delta of Q2 on B. Now you can write here epsilon closure of Q0 on B. So Q0 on B self. So Q0 union Q1 on B. So there is no move. Okay, there is no transition for input B. So phi union Q0 Q2 on B. So Q2 on B. Again it's a Q0. So you can simply use epsilon closure of Q0. So Q0 union phi union Q0, it's epsilon closure of Q0. So epsilon closure of Q0 you can see Q0, Q1, Q2. So the delta function of Q0 on B is Q0, Q1, Q2. Just note down here. So delta function of Q0 on B is equal to Q0, Q1, Q2. Okay, we have find out the state with both the transitions, right? Both the input symbols A and B. Now just move with the next one, that is Q1 on A. Q1 on A. So obviously here it will be Q1 on A. Q1 on A. So I will write once again. Okay. See. Now you can expand this one. Epsilon closure of delta of Q1. Q1 means Q1, Q2. So Q1 comma Q2 on A. On A. Okay. Now epsilon closure of expand delta of Q1 comma A union delta of Q2 on A. And here you can find out from the NFA. So Q1 on A, it is Q1 union Q2 on A. It's again Q1. So that is nothing but epsilon closure of Q1 union Q1, which is nothing but Q1, and the resultant will be Q1 comma Q2, because epsilon closure of Q1 is Q1 Q2. So the delta function of Q1 on A is equal to Q1 Q2. Note down here. So delta of Q1 comma A is equal to Q1 Q2. Right? So hope you understood this procedure. Just apply this function. Apply this function for each and every transition over the every input symbol. Now just note down Q1 on B. Q1 on B. And here you can write, see, epsilon closure of Q1 is nothing but Q1 Q2. So Q1 Q2 on B. Right? So here you can write, expand it, Q1 on B and Q2 on B. So here you can write down epsilon closure of Q1 on B. Q1 on B. There is no transition. Union Q2 on B. Q2 on B, again it is moving towards a Q0, right? Q2 on B, moving towards Q0. Now you can see epsilon closure of Q0. So epsilon closure of Q0 is Q0, Q1, Q2. So Q0, Q1 and a Q2. So delta function of Q1 on B is Q0 for Q1, Q2. So note down here. So delta dash of Q1 comma B is equal to, so Q0, Q1, Q2. Right? Now let us check with the Q2. Right? We have completed the two states over the transition over the input symbols A and B. Now we have to find out the transitions for input symbols A and B of Q2 state. So now let us go with the Q2 on A. So here instead of 1, it is a Q2 on, it is A. Now Q2 on A. Now you can see epsilon closure of delta of epsilon closure of Q2 is nothing but a Q2. So Q2 comma A. So epsilon closure of Q2 comma A. Okay, delta of Q2 comma A, delta of Q2 comma A, it is a Q1. So epsilon closure of, it's a Q1. So the states will be Q1 comma Q2, because the epsilon closure of Q1, you can see here Q1 Q2. So this is a Q1 Q2 for Q2 comma A. So delta, the transition function of state Q2 over the input symbol A is a Q1 and Q2. So just note down here. So Q2 on A is equal to Q1 Q2. Now just go with the another input symbol, that is a B. Q2 on B. So just go with the Q2 on B and here also it's Q2 on B, and you can see delta of Q2 on B, it moves to Q0. So epsilon closure of Q0, so epsilon closure of Q0, then the resultant will be, so Q0, Q1 and Q2, because epsilon closure of Q0 will be Q0, Q1, Q2. So just note down here, delta function of Q2 over input symbol B is equal to Q0, Q1 and Q2. Right? So these are the states, these are the transitions we found for each and every state. So Q0 on A, Q0 on B, Q1 on A, Q1 on B, Q2 on A, Q2 on B. Now you just start drawing the NFA without the epsilons. So these are the states. So simply you can consider this as one state and this as another state. So you can observe here Q1, Q2 is one state, Q0, Q1, Q2 as another state, and you can observe only two states are there, and you can draw the diagram. Or else simply use the same states. So Q0, Q1, Q2, sorry. So we'll take the three states here. So I'm taking the three states here. Okay. So Q0 on A, it moves to Q1 and Q2. So simply just go with this one, A, and it also moves to Q2. Q1 on B, it moves to Q0, Q1, Q2. So give that self for the B. Okay. Next, Q0 on B, it's go to Q1. So here QB and a Q2. So Q2 again you can simply write it as a B. Okay. So Q0 on B, Q0, Q1, Q2. So Q0, Q1, Q2. Now Q1 on A, Q1, Q2. Q1 on A, Q1, Q2. So give the self for this one and Q2. Here it is. Right. Next, Q1 on B, Q0, Q1, Q2. Q1 on B, Q1, Q0, Q1, Q2. So Q1, Q2, and again this is Q1. Q1 on B, Q0, Q1, Q2. Next, Q2 on A, Q1, Q2. Q2 on A, Q1, Q2. So Q2 on A, Q1, Q2. So here it will be A and it will be A. Okay. Q2 on A, Q1, Q2. Q1, Q2. Q2 on B, Q2 on B. Again 3. Q2 on B, Q0, Q1, Q2. So Q2, Q1 and so this is the NFA without epsilon. This is the NFA without epsilon, right? So simply by using this function, transition function, just draw the diagram. Or else you can simply represent the states. These are the states, right? So Q1, Q2 as one state, Q0, Q1, Q2 as another state, and you can just transit from one state to another state, right? Now, so the process is not over. So we need to find the final state. So initially there is a Q2 is the final state. So just give the Q2 as a final state and observe here. So what is the rule? So F union Q0 if epsilon closure of Q0 is having F as member. So what is F here? So F is a final state in first one, that is a NFA with epsilon. So F is equal to Q2. So we need to find whether Q2 is a member of epsilon closure of Q0. So what is epsilon closure of Q0? So epsilon closure of Q0 is having the Q0, Q1, Q2. So here you can find Q2 is a final state of this one, and which is a member of Q0. So the final state should be having the Q0. So F union Q0. So F dash is equal to F union Q0. So F is nothing but a Q2, and Q0 should also be included here because the Q2 is a member of this final state. So obviously the Q0 will also be the final state. So this is the transition function, this is the NFA without epsilon for this NFA with epsilon. So just remember the three steps. One is, first we need to find the epsilon closures, And then the second step, we need to follow this function, and the third step, we need to find the final state. Right? So once again I am repeating why we have to convert this NFA with epsilon to NFA without epsilon means, so the feasibility is not not possible. I mean, the conversion, this implementation is not feasible for this NFA with epsilon. So we have to convert the NFA with epsilon to NFA, and we have to convert this NFA to DFA before implementation. Right? So implementation of NFA is not feasible. So that also we have discussed in the previous session, that is the differences between NFA and DFA. Right? The implementation part is feasible for only DFA. So we need to convert the NFA to DFA. So if there is a NFA with epsilon, first we need to convert this NFA with epsilon to NFA without epsilon, and then the next step is we have to convert the NFA to DFA. So in the further sessions we will see how to convert the NFA to DFA. Right? So hope you understood this session. So if you are having any doubt in this procedure, please feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.